Hello everybody, this is Dr. Kevin Connors again. We're going to go over the presentation that I did the other day and it didn't have any sound. So this is working now, I can see that. So to better understand food antigens is important whether you're dealing with cancer, Lyme, or just tummy aches, or any condition whatsoever. Because if you've watched any of my other presentations, all disease can begin with the gut, and at least the gut has a component of every disorder. That's my opinion, literally every disorder. And after this, I think you'll better understand why I say that. So food antigens. First of all, what is an antigen? An antigen is just the name that we give anything that stimulates an immune response. So typically a virus that got into your bloodstream would be an antigen because it would stimulate an immune response. In general, antigens are supposed to be, if everything was perfect, the only antigens would be biotoxins, meaning viruses, bacteria, molds, fungus that get into the body to stimulate an immune response. Because remember, what does the immune system do? It does one thing. It kills things. And your immune system doesn't detoxify. Your immune system is supposed to kill enemies. So in a cancer patient, a rogue, rapidly replicating cell, aka cancer, should be an antigen because it's not acting like a normal cell. It should be recognized as an enemy, and the immune system should kill it. And that happens in all of us, probably on a daily basis. Something happens within a cell, it starts replicating, and the immune system goes, what the heck is that? Let's kill it, and it destroys it because it recognizes it as a antigen. So anything that the immune system recognizes as an enemy is an antigen. So why would food be an antigen? That's the problem, right? So food is something we're supposed to eat, digest, break down, and to absorb the nutrients, and for that to energize us and become a part of us and fuel our everyday function. Food shouldn't be an antigen. It should never be an antigen. We're going to explain why and the problem in that for cancer patients and any other patient in this presentation. So the common food antigens, the most common is gluten, and followed by dairy, and then eggs and other things can be food antigens. Why they become antigens is the question that we'll talk about. There are certain tests that you can do to find out these antigens. There's numerous tests on the market. I only like the Cyrex test because it tests for peptides of these things, and I'll explain why. So when we look at gluten, let's use gluten as an example. All right. So if we eat gluten, gluten is the protein that is in wheat. And it's actually, the protein is called gliadin. So the gliadin in wheat should break down into amino acids and then should go across the gut wall, and we should absorb those amino acids. So just a little bit of Physiology 101. When you eat something, it's broken down. So in your stomach, you secrete HCl, and the hydrochloric acid in the stomach breaks down carbohydrates mainly, which would be gluten, and it, or at least the carbohydrate portion of the wheat, and then that bolus of food gets secreted into the small intestine. That first part of the small intestine, that duodenum, is where your pancreas makes enzymes to be secreted into the duodenum, and your liver makes bile that's held in the gallbladder that's then secreted into the duodenum to break down. The bile breaks down fat. The HCl from the stomach is the biggest thing that breaks down the carbohydrates, and then the enzymes from the pancreas break down protein mainly. There's some mixture of that, but that's the main gist of it. So first of all, you have to break down food to its smallest component so you can absorb it across the membrane of the intestinal wall. So the intestinal wall is made up of cells that are tightly packed together, and they have very small little crevices in between them that are actually called tight junctions. So these tight junctions allow only very small particles to go through. And then some particles go through receptors on the epithelial cells themselves that line the intestinal wall. And that's how it gets into the bloodstream and then circulates in the blood, and our body uses those. So when we're talking about breaking down a protein, what is a protein? So first let's take a look at that. Gliadin protein. Think of a protein as a long beaded chain of a pearl necklace. That's the best way I can describe it. And each one of those pearls is an amino acid. And each one of those amino acids are different amino acids. And the sequence and how those amino acids are arranged is what makes up a different protein. So gliadin protein is different than casein dairy protein because of the sequence on the number of amino acids in that beaded pearl necklace. But that beaded pearl necklace is what you ate. So you chewed it up and you broke maybe even some of that pearl necklace into pieces. And then you swallowed it, and HCl doesn't break it down too much, so it goes into the small intestine, and it's that first part of the small intestine that enzymes are secreted, and these enzymes, think of them as scissors. They're cutting up that beaded necklace, and the whole purpose of it is by the time it gets farther down into the small intestine, remember you got 20 feet of small intestine, 10 feet of large intestine, at least 30 feet of gut, that these enzymes are working on snipping it into little pieces so that it gets down to one little bead or two little beads at the maximum for it to go through. And when it breaks it down into one or two little beads, it's no longer gluten anymore. It's no longer casein. It's no longer that protein anymore. It's simply an amino acid. And if there's just one bead, it is solely an amino acid. If there's two beads, then that's called a dipeptide. If there's more than one bead, more than two beads, let's say there's 10 beads, that's called a peptide. So it might be a peptide chain of 10 that was from gliadin. Or it could be a peptide chain of 27 or a peptide chain of 35. And it's still going to be recognized as gliadin depending on how many amino acids are still in that chain. But those should never get across the gut wall because those tight junctions of cells are very closely held together because they're very healthy. And these peptides of 10 or 20 or 30 don't get across, so they stay in the lumen of the intestine until the little scissors enzymes snip them into little pieces until they're down to one or two pieces, and then they can sneak between those cells and get into the bloodstream. And in the bloodstream, they break down into amino acids by themselves, and then our body utilizes those amino acids to build muscle, to go in and build cell membranes and receptor sites and do all sorts of wonderful things. That's how our body works. But the problem comes in is if our cells of our intestine got damaged. Maybe because we had to take an antibiotic, or maybe because we consumed some GMO foods, or maybe because we had flavorings and additives and colorings and we eat too much sugar and junk food and preservatives and chemicals and all this stuff that we eat on a daily basis that damages that cell wall. So that cell wall is now not a tight junction of cells. There's missing cells and damaged cells. And now that tight junction is separated. That's called intestinal permeability, or the common name is leaky gut. So now there's gaps between the cells and damaged cells and broken down cells. So these larger peptides that were never supposed to get into the bloodstream in the first place are now sneaking through these gaps that are damaged in sections of 10 or 20 or 30 and getting into the bloodstream. And if they do so, they're not just amino acids anymore. They're these long-chain peptides. And our immune system goes, "What the heck is that?" Oh my gosh! And what does the immune system do? Does it escort things out of the body? Hey, you're not supposed to be here. You come with me. Let's get you out of the body. No, our immune system doesn't do that. Our immune system does one thing, and it does it well. It kills things. So the immune system tries to kill it. It says, what are you doing here? What is this thing, this giant snake in the bloodstream? Let's kill it. So it fires this response, this Th1, this immune system response, the Marine Corps of the immune system, to go and kill this food antigen. It's a peptide of gliadin. Well, of course, it's not living. It can't die. It's not going to die. So your damaged gut continues to allow these sections of this pearl necklace across, and our immune system is going bonkers trying to kill this. And that in itself is a bad thing, because when we're trying to fight cancer, trying to kill cancer cells, now our immune system is reacting to all this other garbage that it never supposed to react to. These cells that go rogue and start replicating in my liver can now elude the immune response, because my immune response is too busy trying to clean up all these food antigens because they're getting across a damaged gut membrane. And of course it gets worse because these food antigens aren't living organisms, so they don't die. So your Marine Corps side of the immune system continues to try to kill them, and then pretty soon the Marine Corps are pulled off, and the FBI side of the immune system, which is the Th2 side, or the B cell side, goes in there and makes antibodies against them. So now you have antibodies against gliadin peptides circulating in your blood, circulating in the lumen of the intestine, and every time you eat this, you fire this huge immune response again, and you have this chronic ramped up inflammation to these food antigens, where that's not good at all. You can't fight cancer. Your army of your immune system is fighting so many battles at so many different fields that it's very difficult to win the battle of this cancer that's growing inside your body. That's why I like to do this Cyrex lab test. I said there's multiple different labs, and the reason why I like Cyrex is because they test for the different antibodies of the different peptides, not just gluten as a antibody. People come in and they go, well, no, I ran a gluten test. My doctor did a blood test on gluten. Oh, let me see it. Oh, it's a gliadin antibody test. Huh. That means you had to have such a damaged gut that the entire pearl necklace had to get through the gap for your immune system to make antibodies to the entire gliadin. Most of the time, you're not that bad. You got a damaged gut wall, so these peptides, these 10, 20, 17, 32 peptides of gliadin have gotten through, and your body's making antibodies to them. Well, that won't show on a gliadin antibody test. That's the whole protein. It's only going to show on a peptide antibody test. That's why Cyrex is so far superior. So running this test on people is very good. It's not just testing for peptides of gluten. It's testing for about 200-300 different foods that you could have this going on. I just gave you the example of gluten here. So we have to look at that. These peptides cross the gut border. These sections, these pieces of the pearl necklace cross the gut border. The immune system sees them as an enemy. Therefore, they're a what? Right. They're an antigen. So our immune system fires this Th1 response. That's the Marine Corps, trying to kill it, causing this ramped up systemic inflammation. Can't kill it because it's not living. So you'll fire a Th2 response, and what does the Th2 or B cell response do? It makes antibodies. So you've created antibodies against a food, and now every time you eat that food, you're going to fire an immune response. And every time you have this chronic ramped up immune response, the other negative side of it is you're now damaging the gut even more. So you got all these fires going on in your body, and you might not even have any gut symptoms. Zero, none. But you got all these little fires going on in the body. How could you kill cancer? How could you kill Lyme? How could you do it? How could you fight any chronic disease? You just can't. Not good. So we have to see how your body is responding to these things. Clean these out. Get rid of these foods out of our diet for a period of time. Allow these antibodies to calm down. Do things to heal the gut border, so that then our immune system can focus on what we want it to focus on. Okay? The same thing's true with dairy, same thing's true with soy, corn, etc. All these different tests. So we have to test for this. Here's an example of a section of just the first page. This is array 4 from Cyrex. I do array 10 on most people, which tests for, I don't know, 200-300 different foods. So it tells us, do we have antibodies? That's the thing in the yellow and the red. Oh boy, we do. And this person has casein antibodies and whey protein antibodies and oat antibodies and coffee antibodies. Oh, that would stink. And teff and egg and corn. Teff is in a lot of gluten-free things. So they really need to clean those out of the body, because every time out of their diet, because every time they eat something, that's going to fire an immune response, and they're going to have damaged gut borders and not do well. So that's why you look at food antigens. That's why you clean out the diet. This may be a good test to run on everybody. Thing is, it's not super cheap, but it can be very valuable to solve problems that you've been chasing for a very, very long time. So hope this helps. Hope you understand that better. Why we look for food antigens, why it's important for you to heal from all sorts of things, even when, oh my goodness, I got breast cancer. Why would I look at that? I don't have stomach problems. Well, now I hope you better understand that. All right. Thank you very much. And if you want to contact us, the website's on the slides. Thanks. Bye-bye.